In this video, we're going to start talking about surfaces in space. There are multiple different ones. What we're doing first, though, is we're going to look at the definition of a cylinder. So we're going to let C be a curve in a plane, and we're going to let L be a line, not in a parallel plane. The set of all lines parallel to L and intersecting C is a cylinder. The curve C is the generating curve, or the directrix of the cylinder, and the parallel lines are rulings. Alright, the equations of cylinders. So the equation of a cylinder whose rulings are parallel to one of the coordinate axes containing only the variables that are corresponding to the other axes. Alright, next we've got quadratic surfaces. These are the equation of a quadratic surface in space is a second degree equation in 3 variables. The general form of the equation is ax squared plus by squared plus cz squared plus dxy plus exz plus fyz plus gx plus hy plus iz plus j equals 0. And then there are 6 basic types of quadratic equations or surfaces. We've got ellipsoids, hyperboloids, both of those, or hyperboloids of 1 sheet, hyperboloids of 2 sheets, we have an elliptical cone, and an elliptic paraboloid, and an hyperbolic paraboloid. Alright, so on the next page, we're going to classify some of our shapes here, or surfaces. So right here we have a 4x squared minus 3y squared plus 12z plus 12. What I'm going to do is I'm going to divide everything by 12. I want that number back here to be a 1. So if I do that, I have x squared over negative 3 plus y squared over 4 minus z squared minus 1. Move the 1 to the other side. So now we're going to kind of classify this. So if I make z equal to 0, I get a hyperbola. If I make y equal to 0, I get nothing. And if I make x equal to 0, I also have a hyperbola. Alright, next one here. I'm going to solve this one for x. So we get x equals y squared plus 4z squared. Now if z equals 0, I get a parabola. If y equals 0, I also get a parabola. And if I make x equal to 4, get y squared over 4 plus z squared over 1 equals 1, which would get me an ellipse. So this shape is an ellipse paraboloid. Alright, the bottom one is probably the hardest one. What we're going to do is basically complete the square for each of our variables. So what I'm going to do first is I'm going to rearrange these. Then we're going to complete the square on each one of them, meaning we have to factor out a 2 for the y's. And we got to make sure we add all of those to the other side, factor it out completely. Divide everything by 4 so we're equal to 1. And then this is going to be an ellipsoid that is centered at 2, -1, 1. And last section here, we got to look at surfaces of revolution. So if the graph of a radius function, I'm going to call that function r, is revolved about one of the coordinate axes, then the equation of the resulting surface of revolution has one of the forms. 1, we either revolved about the x-axis, which means we get y squared plus z squared equals r of x squared, or we revolved about the y-axis, which means we have x squared plus z squared equals r of y squared, or we revolved about the z-axis, which means we have x squared plus y squared equals r of z squared. Alright, so we want to find the equation of the surface of revolution formed by this equation and that one. So for part A, we're going to do y equals 1 over z. We get x squared plus y squared equals r of z squared, which means we've got x squared plus y squared equals 1 over z squared. Or for part B, we have x equals 1/3 y to the 3/2, which is going to be our r of y. So x squared plus y squared equals, or z squared I should say, equals r of y squared. Plug in our r of y, square it, and get x squared plus z squared equals 1/9 times y to the 3rd. And that is it.